Welcome to Recovering Evangelicals, a podcast for people who were once very comfortable in the Christian faith until the 21st century intruded and made it very hard to keep on believing. I'm your host, Luke Jansen.
And I'm Scott Dyer.
Last week we introduced you to the topic of fine-tuning of the universe, a commonly used argument in the Christian apologetic toolkit. We took the time last week to explain some of the basic definitions and models and arguments at play here, so that we wouldn't lose too much time doing that with our guest experts. We emphasized that fine-tuning can mean three very different things. The fine-tuning needed to produce a universe full of usable stuff, or the fine-tuning needed to produce life, or the fine-tuning needed to sustain life. Those are two different things, producing life or sustaining it, and we'll deal with those two next week. But this week we're going to focus exclusively on the fine-tuning needed to produce a universe full of usable stuff. What do we mean by usable stuff? Well, we talked last week about the fundamental particles and the atomic forces that hold them together to produce electrons, protons, and neutrons, as well as the forces that act over longer distances, electrostatic forces and gravity, for example, that pull those together into planets and stars. And we mentioned that those forces needed to be balanced to an exceptionally high degree, or else those fundamental particles would never pull together and there would only ever be an ever-expanding cloud of fundamental particles, or on the other hand, they would pull together so quickly and tightly that there would only ever be one gigantic super ball of a black hole that gobbled up everything. And the degree of balancing needed to get that optimal middle ground, a universe full of electrons, protons, and neutrons, all the way up to planets and stars, was comparable to balancing a pencil on its sharpened tip. Today we're going to dig down deep into all of these ideas, and we'll do that with two guests, both of them with university training in areas directly relevant to this topic, although they took very different paths to get there. Elie Feder has a PhD in mathematics, and Aaron Zimmer has training in physics, as well as some mathematics and philosophy. They both have extensive rabbinical training, and they co-host a podcast called Physics to God, and have done a whole series of episodes looking specifically at fine-tuning of the universe. So Elie, Aaron, welcome to the podcast.
Yes, welcome.
Thank you. It's a pleasure to be here.
Congratulations on your podcast. Maybe you want to talk a little bit about how that came about and how it's going.
So Aaron and I have been working on fine-tuning for a very long time, maybe about 12 years or so. And the story began, I guess, Aaron was reading a book from Lee Smolin called Life of the Cosmos.
Yeah.
Right. And in that book, he talked a lot about the constants and how these constants of nature are fine-tuned. And basically, Lee Smolin's an atheist, but basically he made his computation of these constants being, perfectly tuned for our universe to emerge by chance as being, 1 in 10 to the 200th power, something like that. So at the time, Aaron told me, we talked a lot about science, we studied the Talmud together and, rabbinics, but we also talked a lot about science, philosophy, all kinds of things. So Aaron said, this is unbelievable. This points towards God. This is like Smolin isn't saying that, but this is where it's headed. This is where it points to. So, I pushed back a little bit, but we went back and forth. And we started off, I said to Aaron, hey, you got to teach this. You got to show this to people. So he started trying to teach it to a few people. But the problem is, as you guys might know from your experiences, physics is scary and it's hard to convey physics to people. It's scary. Again, math, physics. Again, I teach math. I know the ideas. We try to teach these topics to people. It's oftentimes people get scared. But at the same time, Aaron was very excited, saying, this is an argument. This is convincing. This is, again, we weren't especially convinced by arguments from biology. We thought, it's interesting, but we thought this is, Aaron was telling me, this is much better. This is a much more solid argument.
Well, okay, we proceeded to try to do a series of blog posts on it. It was about 12 years ago. After we did those blog posts, which were generally well received by our friends, we tried to write a book. And we kept writing it over and over, and it took us about 10 years. And then when it more or less was finished, it was in a manuscript form, and we wanted to publish it. But, we realized we had been, writing a book for 10 years, but we're rabbis and we have, private lives. We hadn't worked on building any kind of public persona and, building a following, things like that. And we were just aware if we just publish a book, it's just nobody's going to read it. So we started a podcast and we made it a lot lighter, a lot more fun, where we present the material in a dialogue form. If you've listened to any of the episodes, then you'll see it's much more accessible and it's a more fun interaction between the two of us. Right now, we've only presented a third of the book, part, what we call season 1, about the fine-tuning argument. That's what we've already done. We're going to do season 2 about the multiverse. And that's coming out later this year. It's going to be about 13 episodes, really understanding the multiverse and what's wrong with it. And then season 3, we're going to do about God, because, a lot of people, they do the fine-tuning argument and they just say, well, it shows there's an intelligent cause and therefore it's God. And then they just insert their favorite God into what that means, and we're trying to show that the idea of God that emerges from this argument is a specific concept of God that's logical, that's coherent, that can be defended, that's intuitive. It emerges from proper scientific thinking, uses the right categories, and it's going to require an entire series to do that, as opposed to just saying God and walking away. So those are really the 3 parts of our podcast. Season 1 is done. Season 2 and 3 is coming.
Oh, very good. Very interesting. Very interesting journey. I'm curious, within the Christian theological world, these kind of things had a pretty prominent place. There's a lot of work been done in this area. Is that true in Jewish theology as well? Is there as much interest into the interface between science and theology as relevant in that circle, in that world, as it is in mine, I guess?
Yeah, there's a long history of it. Again, there's the talking about it over history and then talking about more recently. But there is a long history of great Jewish thinkers like Maimonides or someone in Bachya ibn Pekuda or Saadia Gaon. And there is a long history of them talking about arguments for God, design arguments, various different forms of arguments, the cosmological argument, things like that.
Okay.
But as of late, I think it's become less popular with time. And over the years, it seems like maybe the modern scientific revolution seems to have dissuaded people, especially also Darwinism seemed to dissuade people from these types of arguments. And there are some people in the Jewish world, but it's not very prevalent.
I think it's a split. It's a split. Some people, it very much has to do with the Jews' attitude towards modernity in general. So like the ultra Orthodox, who just in general insulate themselves from the modern world. So they view science as part of that, partly because atheistic scientists are so anti-religion. I think it's hard for a lot of people to separate science from the attitude of scientists themselves and the world of academia, which has unfortunate results. So it really becomes like a split. The modern Jews who are more open to science pursue this type of inquiry. I would say, but the Jews who are more closed off to the modern world as a whole, they're not too interested in this.
It's interesting that there's a real parallel in the Christian world as well. The Christian fundamentalists tend to be, I might say, almost anti-science, and for the same reasons, because they feel the scientific community has been aggressively against them. And then there are people kind of in the middle, and then on the liberal end of the spectrum, there are those who would go all the, even to the point of Christian atheists and so on. Which sounds like a paradox, but yeah. So,
right. No,
it's just interesting that both communities have very similar kind of responses to modernity, I guess you might say.
Yeah, the relationship between religion and the modern world, that's like a universal problem the past few hundred years between all religions, and the secular modern Enlightenment and Renaissance. That's just universal. I don't know, everybody's got to deal with those issues, and not easy to deal with,
Right. That's why a lot on our podcast, Physics to God, we're not talking about any specific religion. We just think this is a problem that religious people at whatever religion you're in face, the challenge of modernity and of atheism, and we're just trying to support the fact that modern physics, whereas atheists would like you to believe that modern science shows that God doesn't exist. On the contrary, modern physics, fine-tuning, indicates a cause, an intelligent cause for the universe.
Right. Okay.
Okay, guys, we should really jump in. There's a lot of ground we want to cover. Aaron, Elie, a few months back, Scott and I explored in really great depth and detail the idea of design in biology. And in the end, the story that they presented to me wasn't convincing. But fine-tuning of the universe is an idea that has held more traction with me. On one level, it can look like it's the same kind of thing, but it is very different, in my mind at least, in many different ways. So let's talk about that. But I want to put some boundaries on this discussion, mostly because we only have this 1 hour. Last week, we introduced our listeners to the concept of physical constants and equations that dictate what the universe looks like and how it works. Just some fundamental ideas, and you can cover that again as well if you feel a need to do so. Some of those constants and equations determine whether the universe would even exist at all, and some of those determine whether the universe will produce any life, at least life to the extent that we understand life. I want to make sure that we keep that distinction in mind as we talk, and to try not talking about fine-tuning the universe to permit life, because I'm a biologist and I know that life can flourish across an incredibly wide range of conditions, and we talked about that last week. Instead, I want to talk about the fine-tuning that is needed to produce, and I apologize in advance here, I'm going to use a really technical term, the fine-tuning needed to produce usable stuff. As I understand it, it's far more likely that the initial conditions would produce a gigantic cloud of unconnected fundamental particles like strings and quarks that are too dispersed to interact, or to produce one gigantic super ball of stuff that's too firmly compacted together to produce anything useful. But here's where it gets interesting for me, at least. To produce a universe that has small bits like protons, neutrons, and electrons, and large bits like planets orbiting stars, that apparently requires razor's edge fine-tuning. And the analogy that's almost always used is balancing a pencil on its sharpened end, and I know some physicists don't like that analogy. So let's talk about those two extremes and that delicate fine-tuning.
Okay, so I'll just want to introduce that we're very happy that you made this distinction, because we do think that people often present the fine-tuning argument as that the constants are fine-tuned for intelligent life. And we really think that's a mistake or an overreach, if you will. And there's, I think oftentimes religious people are trying to use an argument from fine-tuning to prove religion, to prove divine providence, to prove the importance or centrality of man in the universe. And we think that the evidence doesn't quite point to that. The evidence of fine-tuning points, as you're saying, points to fine-tuning for atoms, for molecules, for planets, for galaxies, for stars, for galaxies, and for life. But it's the building blocks of intelligent life. And there's maybe a small thing about the fine-tuning for carbon, but that doesn't quite get to intelligent life anyways. So again, it seems like people do overreach. And I think, again, that comes from both sides, actually. It comes from religious people who are trying to use this argument to support religion, to support divine providence to man. And it also comes, and we'll talk about this a little bit later, from multiverse scientists, because in order for multiverse to truly explain fine-tuning, they have to posit infinitely many universes, and also that the typical universe, that what we see is basically what the typical universe with intelligent observers would see. And they try to use probability to explain why it is that we exist in the way that we do. And for that to be the case, they have to explain but the problem is they don't have to explain us and our existence. They have to explain all the rest of our universe and the 100 billion galaxies with 100 billion stars each. And how do you explain all that? And we'll see that the answer is ultimately they claim that our universe is the typical universe with intelligent observers. And the idea is they claim is that fine-tuning is not just fine-tuning for, I forget your sophisticated word, for interesting stuff, but that it's fine-tuning for intelligent observers. And again, we have to get to this, and we're going to get to it later, hopefully in our conversation and more in our series. But it's really, physicists, multiverse scientists also must maintain fine-tuning is for intelligent life. We don't think that the evidence indicates that at all. And that's one of the things we think we do differently about the fine-tuning argument, is that we are not focusing on fine-tuning. We're trying to show that there's an intelligent cause of our universe who fine-tune their universe to bring about all of the order and beauty and complexity throughout our universe, including life, but not life in specific. It's really all the building blocks and everything else, which, bigger and smaller, which demand the fine-tuning of the constants in order to bring everything else about.
So is it you hear sometimes people say, why is there something instead of nothing? Is that kind of what we're dancing around a little bit?
Yes, in a sense. See, we think I think as Luke said well, is that it's not that there would be nothing, there would be like a chaotic sea of fundamental particles just banging into each other, but they wouldn't form any structure, anything of order. You wouldn't have atoms, molecules, rocks, planets, galaxies. You wouldn't have, so you'd have something, but it would just be chaotic. Nothing
Uninteresting,
interesting.
not
Yeah.
usable.
Yeah, not
Right.
usable
Or
stuff.
that gigantic super ball of compacted whatever. But there's this
Right.
balance. So tell us about that balance, that fine tuning that centers the development of the universe in that narrow range in the middle, not this dispersed cloud of fundamental particles or this compacted ball of everything, but a very diverse range of bits and pieces, atoms and planets and stars.
Okay. So the key thing to realize is that there's something that precedes your question. Okay. People focus on fine tuning being the problem. Fine tuning, how do you balance that pencil? What would happen if it tilted to the right, if it tilted to the left? That is obviously very important with the fine tuning argument. But the mistake is to realize that there's a scientific background for that. Okay. What do I mean by that? Forget about fine tuning for a second. You have to understand the problem, the fundamental problem that exists with the constants themselves. And this is something that physicist Richard Feynman spoke about. He called it the great mystery of the constants, one of the greatest mysteries in all of physics, in his book QED in 1985. The problem is like this. Scientists, and physicists in particular, are trying to explain the natural world by simplifying it and by explaining the great diversity of all the phenomena that we see and by explaining them how they emerge from simple equations and simple laws. And as those laws unfold, the consequences of those laws unfold, that's how you have all the chemistry that follows and biology that follows from that and astronomy, they all come from basic fundamental laws of physics. And scientists are trying to unify the laws of physics into fewer and simpler, more beautiful and elegant laws. And the ultimate dream of scientists, at least in the late 20th century, was to find a theory of everything, a theory that would unify all the laws of nature, quantum mechanics and gravity, that's described by general relativity, and would be a short, simple equation that they often describe, saying they would like to be able to write it on a t-shirt, something simple, and that would be the fundamental law theory of everything. And from that, everything else would follow. The problem is in the laws of physics that we have, there are 25 of these constants of nature, these numbers that determine the quantities. Now, you spoke about this on your show last week, how, for example, how big an electron is. An electron is a fundamental particle. It can't be broken down into anything else, but how big is it? So it has a mass. Again, that mass determines how much it weighs, let's say if you put it on a scale. Or if you had two electrons and they both have charges, how strong is the interaction, repulsion between them? That's something called the fine structure constant. And that's a quantity, how strong it is, how much do they push away relative to how much they were, let's say, be attracted by gravity, something like that. And these numbers, these quantities, they're part of the fundamental laws of physics, and they can't be derived from anything else. They're called fundamental constants of nature because they're always the same, they're constant, and they're fundamental because they can't be derived from anything else. Physicists don't know them through any theoretical considerations. They're just measured, and then they're put into the equations because everything needs quantities. If you're going to say two electrons repel each other, well, how much? You need quantities. Everything is described by mathematics and equations. Math needs quantities. And the question is, how do you explain a number? For example, the number that describes the fine structure constant is 1 over 137.039999, 039 or something. So they just measure that and then they put it in. How do you explain that? How do you explain a quantity? And can you explain it by anything deeper, or is it just the base of reality is these 25 numbers that just it's a list of data. It's 25 numbers. They're complex numbers. They're not simple numbers like 2 or pi. There's not just 1 or 2 of them. There's about 25 of them. They're ugly, and physicists are looking for something beautiful. It's a little bit more of a subtle point. We developed that on our show a little bit, but they're just like, there's many of them. They're complex. They're ugly. They read like a list of data. They just don't seem to be what physicists are looking for in a fundamental theory of everything.
The analogy we used last week was the kid in grade school memorizing the facts that there are 1,760 yards in a mile, or 16 ounces in a pound, or 14 pounds in 1 stone, but 2,000 pounds in 1 ton. And that kid asking, why? How do you explain that? Who decided it should be those numbers?
And that's the problem. Feynman called that the mystery of the constant. It has nothing to do with fine tuning. It's an
So-
intrinsic problem. Yeah. Go
Can I
ahead.
just ask this? What a fair analogy to this, and you're mathematicians, I am not. But I know at least this much. Like in Euclidean geometry, for example, there's a starting point, right? We make some assumptions, and everything goes from those assumptions. So the shortest distance between 2 points is a straight line. I guess I think that's one of them. But
Yes.
there's a few very basic things that are not proofs. You can't prove them. You just accept them, and then you move from there. Is it kind of like that with these constants that they're almost like assumptions? They're almost like they're just givens?
Okay. Yes and no. Okay.
Okay.
So it's very, yes. So for example, the qualitative theory of everything that scientists are looking to derive, that is a first principle. That's just an axiom. You have to assume it, but once you assume it, it explains everything else.
Okay.
The question is, are these 25 numbers like that you just have to assume them?
Right.
Which it's one thing to assume the shortest distance between 2 points is a straight line. That's a reasonable assumption. It's intuitive. You could argue it's self-evident, but 1 over 137.03999, like it's not self-evident. Where does it come from? It's just very, a physicist, his mind rebels against saying that is a first principle. It's an axiom. It's just, there's no intuitive reason. It's just arbitrary and ugly, and that's the problem.
Again, like the fact that there are 1,760 yards in a mile or 16 ounces in a pound.
Okay.
So if it is the case, if it is a first principle, these 25 numbers, that's the mystery. Is that really the case? That just doesn't seem to be what lies at the heart of reality. And if they're not fundamental, how do you explain a number like that? That is the mystery. And it has nothing to do with fine tuning.
Can I ask about another analogy? And I know you really want to get onto this.
No,
we're not in a rush.
Go ahead.
Okay. This gets more at Scott's question, which is not the same as the point you're making, Aaron, which is just these numbers make no sense. We don't know where they derive from. That's your point. But Scott was saying, do we assume or measure? So as I understand it, Einstein came up with some equation for the universe, but he didn't like the idea that the universe was always expanding. So he assumed, what I understand, the cosmological constant was 0 or 1, I forget which, but he assumed a value. And later, so astrophysicists did some actual measurements and found, no, there's a number there. And it looks like what Aaron was saying, it's a number with a strange set of digits. But the point is, Einstein initially assumed, but astrophysicists later measured, and they came up with different numbers. Is that fair to say?
Okay, so that's interesting. It's good. It illustrates the history of the cosmological constant, illustrates this point. Originally, Einstein assumed it was 0. Okay, and that's a perfectly reasonable assumption. 0 is a nice number. You know what I mean? That's a good number. If the number is 0, nobody's complaining about 0. You can work that out in a qualitative
Except
way.
Aristotle, maybe.
So, yeah, exactly. So the problem with Einstein with 0 was that according to the equations of general relativity, then the universe should be expanding if it was 0. And if the universe is expanding, then Einstein was smart, then the universe has a beginning. And Einstein writes this, that he didn't want the philosophical implications of a universe with a beginning. Where do you go from there? If the universe has a beginning, well, how did it start? And he just didn't want to engage in that he didn't want that to be the philosophical reality and all those problems. So what he did was he posited a cosmological constant that was non-zero in order to perfectly balance out gravity. But it became incredibly fine-tuned, where it had to artificially be a specific number in order to balance out gravity, so the universe would become perfectly steady, where gravity would be balanced out by cosmological constant and the universe would be a steady state. Once Hubble measured the expansion of the universe by observing galaxies that were receding from us, then it became known that, like the equations of general relativity predicted, the universe is expanding. Einstein called the introduction of a non-zero cosmological constant his greatest blunder, because he should have just trusted general relativity and said the universe is expanding. It would have been the greatest discovery in the history of mankind that he almost could have predicted, but because he didn't want to entertain the idea of a universe with a beginning because of all the philosophical problems that come with that, so that's why he introduced it, and then he took it back. Cosmological constant was 0, and the universe is expanding. Okay, it has a beginning, but that's a problem. Scientists are very clever. They came up with another way of resolving to get rid of God anyway, so that wasn't a problem. Then in 1998, scientists measured the cosmological constant, and it turned out it was non-zero. Okay, and Einstein was, okay, now it wasn't Einstein's value, but the universe is expanding, but it's not only expanding, it's accelerating. It's expanding at a faster and faster rate. And it's a non-zero cosmological constant. And the problem is why is it non-zero? And it's this incredible tiny number with 120 decimal places, 0.0000, about 120 decimal places. If it had been a little bit bigger or smaller, the universe would either have expanded too quickly before at the very beginning, or would have collapsed in on itself. It's the most extreme example of fine-tuning. It is what convinced all scientists about fine-tuning this cosmological constant. And the entire problem is that it's not zero. And then how do you explain it? Where does it come from?
Wow.
Okay, so we took you off on a rabbit trail. We interrupted you, so you were in the middle of your point.
Okay, so maybe I'll let you take
Okay.
over here. So
Okay,
where
fine.
fine-tuning comes
Yeah,
from.
so basically, the point of these constants is this mystery of the constants preceded fine-tuning. It was a mystery of how in the world you explain numbers. We're trying to explain everything in our universe. We don't want to posit that the basis of our universe are these beautiful laws and 25 numbers like 1 of 137.035999184. That's not, that wasn't, that's what Feynman was saying. He said every physicist should put this number up on his wall and try to, figure out how do we explain these numbers. This was a problem. It's a mystery. How do you explain these numbers? Then over time, in the late 70s, 80s, culminating in 1998, was this discovery of fine-tuning. And the discovery of fine-tuning was that these numbers were not as arbitrary as they had seemed. It had seemed to Feynman that the number 1 of 137 could have been any number. And what's really the difference? In terms of the underlying fundamental laws of physics, there really is no difference. As Scott said, it's in a certain sense an input. The number could have been anything. And it's true. From a fundamental physics standpoint, it really could have been anything. But what scientists discovered with more and more as time went on is that if you change those numbers, yes, it's true. Fundamental physics and the equations of fundamental physics would be exactly the same, not except the quantities, the strengths would change. But what would happen is that those constants, those laws of physics, those constants wouldn't result in, as we went forward, it wouldn't result in the emergence of any structure, order, or complexity. You wouldn't be able to have stable atoms. You wouldn't be able to have molecules. You wouldn't be able to have planets or stars or galaxies. And the idea is that all the other sciences, physics itself does not demand fine-tuning. But in order for physics to, as the universe unfolds, to be able to produce anything of order and complexity, anything which we consider interesting, those numbers have to be tuned to specific numbers or within a very small range. And this is the discovery of fine-tuning. Physicists realize that we don't have to just posit these are just the axioms that are just plugged into our universe, or just to say maybe we'll one day discover a mathematical equation which will somehow explain how these numbers emerge. We found our explanation for these numbers. These numbers are the special numbers which are necessary in order to yield our unbelievable universe as it goes forward. And that became the question now for physicists.
Before we get to the question.
Okay, go ahead.
So just see conceptually, this is the key point. Fine-tuning is coming in and solving the mystery. It's showing you your mystery is these numbers are just arbitrary random numbers. What are they, 137? What is that number? Now fine-tuning is showing you have some knowledge about this number. It's not just a random number. It's the number necessary in order to have atoms. It's the number necessary in order to have stars. It's the number necessary in order to have galaxies and not have the universe collapse in on itself. It's giving you knowledge and ideas about the numbers. It's solving a mystery that intrinsically lies at the base of physics.
Okay, so this is a naive question. So as a layperson here, how do they know that only that number would yield a universe with any sort of, like, have they tested all other numbers to know that they could not produce a universe with any sort of structure and so on? Like, how do they know that?
Yeah, it's based upon modern physics. How it's the amazing thing is as science develops, you don't test it out. You just see in your equation that if the number could be slightly different, but if let's say it was like instead of 100, 1 over 137 is 1 over 140, a few percentage off, then you would see that the let's say the atoms, the electron and the proton in an atom wouldn't be strong enough, let's say, to hold the electron and the atom together. Or it'd be the opposite. It would just, it would collapse in on itself. The atom wouldn't be stable, or stars wouldn't be able to do nuclear synthesis. Different things go on, but it's based upon your knowledge of physics. If you don't have any knowledge of physics, then but it could be 1 over 150, it could be 1 over 190, it could be anything. It's as physicists learn more and more about the universe, you have to know about stars, how stars work. It's so important. Astronomy, just the knowledge of how stars work. once you have scientific knowledge of how stars work and you understand fundamental physics, you could see if I change these numbers, certain processes just don't work, don't occur. You can find upper and lower bounds. That's what's so key about seeing how fine-tuning is coming in as the clue to solve the mystery of the constants, is seeing fine-tuning as knowledge, as opposed to a gap in knowledge. Fine-tuning is based upon scientific discoveries, how stars work, how physics works, and how that influences the range of numbers that are sensible to lead to a universe with structure and order and complexity.
Okay.
Fine-tuning itself is not the problem. It's the clue that solves the mystery. But why does everybody think fine-tuning is a problem? Okay, go ahead, Elie. Why is it a problem?
Okay, so the problem of fine-tuning, and this is the problem which physicists had to deal with. Once they discovered that these numbers are fine-tuned and that they realized that the values of these numbers, the significance of these values of these numbers is not based upon the internal logic of the laws of physics, but is based upon the future outcome, the result that will emerge from these numbers. How do you explain that? As a physicist, how do you explain the fact that the sense of these numbers comes from the future, from the objective, from the purpose, which it leads to? That smacks of like a teleological explanation. It's that the values, the importance of these values, it lies in the future. And that's not the way physics usually works. Usually physics explains phenomenon based upon prior laws, not based upon what it's going to produce in the future. How do you explain something in the present or in the very foundation of our universe, where the explanation seems to come from the future outcome that will emerge from those laws? And that's a puzzle. That's a mystery. That's how do we interpret fine-tuning? And it doesn't take a far stretch of the imagination to realize that the natural interpretation for that is that the cause of the constants is an intelligent cause, because intelligence is the ability to choose one option from among many for the purpose of realizing a goal. And if you see that, that's exactly what the constants indicate, that the theoretical physics itself has a wide range of possible values of the constants. There's no reason intrinsic in terms of physics why the value should be any particular value, but the cause somehow selected the values for the sake of the future of realizing the objective. Well, that smacks of intelligence. That indicates that the cause is an intelligent cause.
Interesting. So it's kind of like I'm a baker and I want to make a cake, and there's only one way to make it, make it a cake. Right. And so I put the right ingredients. It's very specific, right? And I build that in, stick it in the oven, and it'll come out a cake.
Right. And the quantities are also correct. The exact it can't just be 17 cups of sugar. You can't just say you need sugar. Right. You have to have the right quantity. Exactly. Right. Exactly.
So I'm stacking the deck. I'm making sure that this is going to come out. I know this discussion is probably the most enlightening that I've ever had on this subject. So I really appreciate it.
That's great.
Luke, go ahead.
Well, let me summarize. You've already said it a couple times, but I'm going to summarize it in my words, which I think might be, because we've talked to our listeners for a couple of years now, they know our language, and see if I'm saying the same thing as what you're trying to say. Basically, these constants, there's a lot of these constants with very strange values, very unpredictable numbers they don't make sense. They don't make any intrinsic sense. And so then the answer seems to be that it's not that there is some sense behind them, but that they were actually selected. They were tuned. They were finely tuned. That's the interpretation. And then because the tuning was done on the basis of wanting something in the future, as opposed to being a fallout from the past, now we bring in this idea of intelligence. There was a selection process and an intelligence. So I'm seeing you nodding. It sounds like that summarizes what you've been saying. I know that there will be listeners who will say, but this sounds like tuning of the gaps, or, tuner of the gaps, God of the gaps, that kind of thing. So how do we get around the fact that, let me use an example.
Let me just add one more thing. Just one more thing is the numbers do make sense. They don't make sense on their own intrinsically. 1/137, that doesn't make any sense to anybody. But it makes sense why you have a cup of sugar if you're trying to make a cake. So the numbers make sense if the purpose of the laws of nature is to produce a universe with atoms and molecules and stars and planets and galaxies and life. If that is the purpose of the laws, then it makes sense why these constants are exactly their values or within a very narrow range. They do make sense. but they only make sense if you say the purpose of the laws of nature is to produce a universe. But physicists don't want to believe that that's the purpose of the laws of nature. They just say the laws of nature are that way because they are that way. Why does gravity exist? Because it just does. Why does quantum mechanics exist? It just does. Why are these numbers? These are the numbers. Stop asking questions, right? This is the basis. The basis of nature is just laws of nature. Now, why does the universe exist? Because those are the consequences of the laws of physics, and it just happens to be the consequences. You explain the universe by making recourse to the laws, but over here you're saying, well, the laws don't make sense without saying the reason for these laws are in order to produce a universe. It's reversing the causality in a certain sense.
Yeah.
That's what's so bizarre. They make sense only if you make recourse to the consequences.
Right.
Okay. Now, I was going to use an analogy to emphasize the point that I'm getting at. And again, I don't know how well this analogy is going to work, but so there was a long time that we humans looked at the birds, saw them flying, and we thought, how do they fly? But we just could not figure it out. We tried all kinds of ideas, and we actually tried making our own wings, that kind of thing. And so some people then concluded, well, obviously there's a divine hand that lifts the bird up. Other people, and that was their worldview. They had a theistic worldview. So they said clearly, the divine is carrying up the birds. There were other people who had a non-theistic viewpoint, and they might say, well, maybe the birds have found a way to violate the law of gravity, or they know something about some other dimensions of existence, whatever. And then we just learned a simple law of aerodynamics, and then it made sense. And so getting back to our situation here, we look at these constants that we have derived based on our models, and we can talk about whether we have the model wrong to begin with, but that we look at these constants and they're just not making sense, and so we talk about fine-tuning being the answer, and maybe someday we'll get an analog of the law of aerodynamics where suddenly, oh, that's how it works.
But I think, Luke, this is almost the opposite problem. This is almost saying that they they do make sense, and that's the problem. They make sense, but they only make sense if you're making a cake. They don't make sense if you're doing anything else, right? So,
and the sense that is being made is it produces a universe full of usable stuff. That's what I said we should be aiming for.
Right.
And that's the sense. Okay, so let's carry on. I'm not sure I'm done with that.
I want to take up that question in detail, because everybody asked the question, why isn't this God of the gaps? And Scott, you got it, but I mean, let's just take it up a little bit more in detail.
Yeah.
Okay, if just you said you'll take up the point details versus since I take up this point here is when you say how do birds fly? I don't know how they fly. We don't know. I probably still don't know how they fly. That's complicated. So that's just you're ignorant. You're ignorant. And now you say, well, I don't know. God makes the birds fly. And you're not really explaining anything. There's a gap in your knowledge, and you're saying God did it. That's just an argument from ignorance. That's called God of the gaps. If this is why it's so critical, if during the stage of the mystery, before the discovery of fine-tuning, when Richard Feynman gets up there and says, one of the greatest damn mysteries in physics is where do these 25 numbers come from? Well, what makes this number? And the guy says, you know what? God made it that way. You didn't explain anything. You were ignorant of how to explain these constants. And just by saying that God did it, that's just God of the gaps. That's ignorance. That's ignorance that you're filling in by saying God. You don't really enlighten anybody. Okay?
Right.
That's before fine-tuning. But fine-tuning is knowledge. Now it's saying, I do understand these constants. I do understand why they have their values. They have their values in order to produce a universe. Why do you have 1 cup of sugar, not 17 cups of sugar? You're trying to bake a cake. That's not ignorance. That's knowledge. The only reason you have that knowledge is because you studied stars and you learned how stars work, and you studied electromagnetic force, and you see how that works. You see that if the quantities are different, atoms don't work, stars don't produce heavier atoms. Those all scientific knowledge. And now I see that this number has to be this way in order to produce stars and to produce molecules and atoms and all these different things. There's no ignorance going on here. This is all knowledge. The problem for scientists is, well, if the reason why the fine structure constant is this way in order to produce stars, in order to have stars and atoms, well, that implies that the purpose of the laws of nature is the universe, and that the cause of the laws of nature is intelligent because it operates with a purpose. It selected certain values in the laws of nature for the purpose of producing universe. There's no ignorance going on here. This is just what the knowledge points to. You might not like the consequences or the inferences and the implications of that, but it's not arguing because we don't know where these constants come from. God made them. We know these constants have a purpose of producing a universe. And then we're just inferring if that's the case, then the cause of the constants is intelligent. because it's selecting them for a purpose. So that's the biggest reason. Yeah, go ahead.
Does the multiverse address this in the sense that if there's an infinite amount of universes, then eventually one of them is going to pop out that constant, those
Yes.
constants, right? Okay,
Yes,
so
the multiverse, we'll get to that in a second. The multiverse
Yeah.
absolutely recognizes this relationship between the laws and the resultant universe. That's the only other theory besides intelligent cause that does it. That's why it's so popular. We'll get to that in a second. Just the other reason why.
Yeah, another idea of why this isn't the God of the gaps type of an argument is that it's oftentimes the way it is. Like, for example, when it comes to probably this is more up your alley, Lucas, in terms of biology or in terms of evolution, you could have the theory of evolution, which explains lots of details of the emergence of life in our universe. And perhaps maybe we'll find one, the wings of birds. And let's say we can't explain the wings, or we can't explain the spots on butterflies or the eyes and whatever. And that's a problem. And maybe someone will say, listen, you've explained so much, you have a fully worked out theory of evolution, but there's certain details, certain gaps that you can't possibly fill. And then someone would say, God is going to fill that gap. That's a God of the gaps reasoning, because you have a good theory. The theory explains a lot. Now you find a small detail. We'll say it's likely that detail is going to be filled in by further knowledge as you fill out the theory. And that's why it's unconvincing when you point to one small little piece of a problem in the middle of a well worked out theory and say that points to God. That's not the case when it comes to physics.
Okay. So I think I've heard a similar argument, and I think this was being used in the realm of design and biology, which we said we weren't going to get into. But I'm hearing the same argument. So let me just check with you. I think it was John Polkinghorne that I remember him saying this, and the question he was being asked, or he was claiming he was asked, was why is the kettle boiling? And the explanations could involve, okay, so electrons flowing through the wiring of the stove, or the combustion of the gasoline, of the natural gas, and molecules vibrating faster and faster and faster. That would be one explanation. And he said, but the other explanation is because I wanted some tea. And that would be that explanation that had a future intention, a teleology, I guess, versus one that looked at prior conditions. So it sounds like it's the same argument.
Well, yes, yeah. So I think there's a big difference is that, and this also differentiates the fine tuning in physics from design in biology, is that in biology or in the kettle, you're dealing with a phenomenon which exists, like, so to speak, within the universe. Okay, many years into the development unfolding of the universe. And you're saying is, how did that emerge? Which prior conditions led to its emergence? Which prior conditions led to the kettle or led to the butterfly or whatever other particular phenomenon in biology? See, here we're dealing with the fundamental laws of the universe. When you're dealing with physics, everything is ultimately contingent on physics. Physics yields chemistry, chemistry yields biology, and it's at the core, the foundation of everything are these laws of physics. So the laws of physics, as far as we know it, these are the fixed givens, if you will, like in a certain sense, the axioms of the universe. Everything emerges from them. And we're trying to explain, where did these constants come from? And the constants, they call them constants because as far as we could tell, they're constant. They never change. They're baked into our universe. As far back as we can measure, these constants are fixed. They're built into the universe. And at the fundamental core of our universe, we're saying, how do you explain these fundamental constants, these fundamental features of our universe? And when we study it, we see, as we've been discussing, we see that, well, these constants are the necessary values to be able to produce our future universe. And that's not a gap within our knowledge of the universe and how things emerge. That's a recognition that the core of our universe, the fundamental foundation which everything else emerges from, are values which have significance because of the future, because of their purpose. And that's what points to intelligence. So it's not like we have some prior phenomenon to say, well, somehow there was an evolution of constants. The constants are constant. You can make that up, and you could posit, and we'll talk about that. You could posit that there is some multiverse of all these different values, and they emerge from something. But as far as science is concerned, what we know, what we observe, is that the constants are fixed, and we don't have any way to explain them. They are the way we explain everything else. These are the basis of our explanation. And when we study it, it points to a teleological cause.
Please indulge me for a moment while I pitch a proposal to you, the audience. If you're enjoying these episodes, and the fact that you're this far into the episode suggests to me that you do, then I'd like to ask for something in return. No, not your money, but your support nonetheless. What we ask is that you help our podcast by leaving likes and comments at our Facebook pages and website to increase traffic to our site. And even better, share this with one or more of your friends who you know are also wrestling with faith issues and their evangelical roots. Such a small effort on your part could easily double our audience. I hope you agree that this is worth promoting. And now, back to the episode.
So is this all somewhat contingent on the idea of the Big Bang? If the universe has no beginning, then does this problem go away? It's just this way, and it's always been this way. Now I know that's not a popular idea, but there are some who question the Big Bang, right?
Scientists for a few decades they knew it. For a few decades they knew the universe had a beginning, and now that's gone. Now a lot of scientists believe the universe doesn't have a beginning anymore.
Right. So what does that do? Where does that come into this?
It's not. Discussion? You know what? It's not really relevant. Because the Big Bang is, let's say, the beginning of our universe, or ostensibly what looks to be the beginning of our universe, at least in events in time. But we're dealing with the universal laws of nature, gravity, quantum mechanics, and these constants are just part of the fundamental laws of science, of physics. Even if you have an eternal universe, which before the Big Bang, there's some other universe, cycles of infinite cycles. Some people try to resurrect those theories. Even if you believe in that, the universe is eternal through infinite cycles, you still have laws of nature that govern all the cycles, that govern all the events, and those qualitative laws have quantities. There's numbers. So can't get away from quantities. Physics is always described through mathematical equations, and there's always numbers and quantities in these equations, and it's really irrelevant. Now, I think the Big Bang is, once you know through the fine-tuning argument that the cause of the laws of nature is intelligent, and he selected these values for the purpose of producing a universe, essentially God exists, right? Which, again, there's a little more work there to do to show that. But once you know God exists, then it makes sense to take the Big Bang at its face value and say the Big Bang shows there's a beginning of our universe. A lot of the motivation for Einstein and other physicists of saying the Big Bang does not really indicate the beginning of the universe is because they don't believe in God. Once you believe in God, from the fine-tuning argument, then just face value, the Big Bang is the greatest evidence of creation that's ever been discovered. And there's really no reason to deny it. It's more because of the implication of God, which some people think is philosophically untenable.
Yeah, one of the best definitions, at least that I have heard, of materialism is that the universe explains itself. And basically what you're saying is they're discovering the universe doesn't explain itself.
Right.
And that's a problem.
Yeah.
That's a problem for a materialist.
Yes.
Yeah.
Is that right?
Yes. Yeah, we saw there's a statement by Lee Smolin who says, in his book, it's Time Reborn, I forget, one of those books. He says, it's a first principle is that the universe is everything that there is. So it's if you take that as a given, well, then you've got a problem here. But that's why there's no basis to take that as a given. It's at least an open question. Does the universe has a cause? Is that cause intelligent? And when you study where the evidence is leading, it leads to the fact that we have these constants, which are caused by an intelligent cause for a purpose of bringing about interesting stuff.
Right.
Let me ask this question. This is coming off, it was what Scott asked that got me thinking this. He was wondering about the Big Bang and how some physicists don't think that there was a Big Bang. So getting at the situation we're in now, where some physicists might even question whether there was a Big Bang, and we don't know where time and space came from, we don't know why these constants look the way they are, and we don't know about this fine-tuner. So there's a lot of unsettled questions, and the basic question would be, is it possible we have the model wrong, the initial model wrong? And the analogy, we were talking briefly about this before we started recording, but basically the Ptolemaic model of the cosmos, and this is for the audience now. I know that all three of you already know this, but for the audience, there was the model where the Earth was at the center and all the stars and planets and the sun were rotating around the Earth. And they had this all set up with a bunch of gears. You could set up a model where you turn the crank almost literally, and these stars and planets would go around the Earth. The Earth is in the center. But it didn't answer all the questions. One thing that some astronomers would notice is, hey, by the way, sometimes at certain times, Venus and Mercury go backwards. And that just did not make sense. So then they introduced new gears that would turn those two planets backwards, retrograde motion. In the end, they realized, guys, we got the wrong model. And that's where Copernicus jumps in with the heliocentric model. So that was a long introduction to the question, could it be that we just have the wrong model? And that would explain why constants don't make sense. We don't know what this fine tuner is all about. And the Big Bang, we wonder if it really happened. Your thoughts?
So you have to distinguish between, is something a theoretical possibility? Like, is it absolutely impossible versus is there any reason to believe it? Or does it really make sense given what we know already? So for example, within modern physics, the past few hundred years, everything has been described through mathematics. That was Galileo, one of the founders of modern science. He said the book of nature is written in the language of mathematics. And that's really served scientists incredibly well, physicists in particular. And you have equations, and mathematics is it's quantity, it's the study of quantity. And I don't think there's any real physicist who believes that any theory of everything that's ultimately going to be discovered is not going to be a mathematical equation or capable of being formulated mathematics is so essential because it's like Feynman says, it's like a language that encodes logical structure, and allows you to derive long-reaching consequences because of the precision of mathematics. And it's not really plausible that you're going to have a physics that doesn't include mathematics and quantities. And there's always been quantities in physics for the past few hundred years. And as we gain more knowledge and see deeper and deeper into the levels of physics and we go deeper into the foundations of reality, those numbers become more and more fine-tuned, more and more precise. They don't go away, they just become more fine-tuned and precise. And there's no reason to believe that a theory of everything, that's what physicists have been dreaming of for 50 years or so, is not going to have numbers and it's not going to have quantities. Is it theoretically possible that you'll discover an ultimate theory that's all qualitative ideas, has no quantities, and that somehow it just produces a universe with all these quantities and mathematics? I guess it's not logically impossible. It's just hard to imagine what that would look like. And there's just no reason to believe it. There's no reason to think that you're going to arrive at a system of thought that just doesn't have quantities and that fine-tuning is going to magically go away when it keeps every level of discovery, it keeps being fine-tuned and they keep existing. So just to hang your hat on that possibility, it's really a form of skepticism. It's saying we have knowledge, we have fine-tuning, we see based upon all the knowledge that we have, the cause of the laws of nature and the constants is intelligent because it selected them for a purpose. And now you're just going to say, I'm throwing away the knowledge because maybe one day we'll discover a theory which says it's not true. You could throw away everything. Then maybe gravity isn't true because maybe one day we'll discover a theory that gravity isn't true. Maybe biology and evolution is wrong because maybe one day we'll discover a theory where evolution isn't true. You could throw out all scientific knowledge by just saying maybe one day we'll have a deeper theory which is going to be completely different than this. And then it just ultimately becomes a form of skepticism. When all the knowledge that you have, scientific knowledge, points you in this direction, and there's no reason to really see that anything should change in this regards of removing quantities from physics. It's not really plausible. Things will change in the deeper theory, but it's hard to imagine quantities not being there.
Another point that I'd like to hear from you, this would actually take the argument away from the people who are against fine-tuning. So in other words, this is a pro fine-tuning argument. Just the whole idea that some people say, well, instead of fine-tuning, I just believe it's just luck. It just happened. And we've mentioned a few times now, we're going to eventually talk about the multiverse. We could now talk about the multiverse, or another variant of the same kind of luck of the gaps idea would be basically billions of planets orbiting around billions of stars. So just there's a lot of them out there, and keep throwing the dice and you'll eventually get the right conditions. Or I don't know what you call this, but I call it the cosmic bounce. Basically, the universe explodes into being, and then it contracts and falls in on itself, then explodes and contracts and explodes, contracts, and it just keeps on shuffling the cards, keeps on fanning the deck until finally it has the right conditions. These are all three of those would be basically luck of the gaps explanations. Your thoughts on those?
Right. So I guess there's a few different versions. So the first question is assuming we have one universe. Okay, they have to split this up between assuming there's one universe or assuming there's infinitely many universes. So assuming there's one universe, luck is just, physicists state this, there's a Leonard Susskind said this in an interview, is that maybe people held out the hope for that. But I think specifically with the discovery of the fine-tuning of the cosmological constant, which is fine-tuned to like 1 in 10 to the 120th decimal places, it's just the degree of luck. Just to say we have one universe, and it happens to have numbers which are so precise. These are the only numbers which would produce our unbelievable structured ordered universe. And the reason why the constants are that way, they just happen to be that way. And the universe, we're fortunate that they are that way because of just that their ridiculous luck. That's something which physicists are not willing to tolerate. It's like, I think Frank Wilczek says something like strange credulity. There's physicists, there's many quotes of physicists who say that the degree of luck, you can get lucky, once in a while you can get a good hand in poker or whatever, but to get perfect hands 1,000 million times in a row, the numbers become ridiculous. That if there's one universe, just to say that we just happen to get lucky, it's like the degree of luck is just beyond credible. So that's assuming there's one universe, and that's why physicists nowadays are largely turning towards the multiverse.
But what about other reasons? Sorry to interrupt, but I'm just curious. What about a cyclic universe? There's one universe, but it's cycling over an infinite amount of time. What about that?
Right. Yeah. So again, that there's two versions of that, but
okay.
The plain interpretation is even if it's cycling time and time and time again, the laws of nature and the constants of nature aren't changing. Those the laws and the constants are fixed. So they're going to have to posit not only that it cycles, cycling big, small, crunch and expansion, that on the plain interpretation, the values, the constants, the laws of nature are what are governing these interactions and the expansions and the crunches.
Oh,
and
yeah.
The laws of physics, see, that would be in terms of chances to get life or chances to get emergent phenomenon. But the fundamental laws of physics is no indication that they're changing each time it crunches in.
But if the laws of nature did change every time there was a crunch and expansion, then it would just be a multiverse. You could have a multiverse where you have an infinite number of universes as successions in time, like a temporal multiverse, or you could have a multiverse in space. Conceptually, there's no real difference. It doesn't ultimately matter. All the problems that plague a multiverse, an infinite number of universes, which I guess we'll discuss pretty soon, it sounds like, there's no real difference whether they're in time or in space. It just becomes another version of the multiverse.
Right. Okay.
There's a lot of versions of the multiverse. So I think Brian Greene in his book has like 10 or something different versions of the multiverse. But ultimately, in order to explain fine-tuning, there's different ways to get these different multiverses. But to explain fine-tuning, they all amount to the same thing: that you have infinitely many universes which have different laws, different constants. And then because by chance, you're just going to happen to have the right constants, the right laws in one universe, and we just happen to be in that universe. So therefore, there's nothing to ask. That's how all the versions of multiverse, however they emerge, end up amounting to that same bottom line.
Right. So maybe it's a good time to just get into that.
Okay. So what are the problems with multiverse? Okay. So we're releasing season 2. Later this year. We're planning on having 13, episodes around same like half an hour each. We're going to go through this in depth. So here's just going to be a shorter version of the whole thing. We're not going to be able to get into the full detail. Basically, every multiverse has these 3 premises: infinite numbers of universes, and you have to justify them. You can't just say there's infinite number of universes. Got to be reasons to do that. Scientists try to justify the fact that there's an infinite number of universes in various ways. The way that seems to be most popular and that has the most grounding is this theory called eternal inflation, which is like in a certain sense, a natural extension of a theory of inflation. I don't want to get into the details here. It has something to do with, it's a modification of the classic Big Bang cosmology, where Big Bang says the universe started, at a certain point in time, 14 billion years ago or so, and it's expanded ever since. Inflation says that it expanded very rapidly at the very beginning of the universe. And if you model inflation in the simplest way, it will lead to inflation never stopping and occurring in many different parts, and you'll end up with infinite number of bubble universes that are causally unrelated to each other. That's how scientists try to, which it's, of all the 3 things, again, I don't really believe there's an infinite number of other parallel universes that nobody can see, but that's actually the one that they have the best job of establishing. Okay, well, so whether or not you want to believe it, that's actually good. Insofar as multiverse goes, that's actually not bad. The second premise they have to establish is that the constants of nature change from universe to universe. If the constants of nature are the same in every single universe, it's not going to help you. Then you have to, right? It's like you're not explaining they're all the same. Why are they? The same problem exists. You just have it an infinite number of times. It just doesn't solve anything.
You're just making a lot of cakes.
Yeah, right, exactly. Every single cake has exactly the right amount of sugar. So you got to have it right. Exactly. You have to have an infinite number of cakes. Every cake has a different amount of sugar in it. The one cake that you're eating has the right amount of sugar, and the reason why you're eating that cake is because that's the only one that worked out. That's the only way multiverse works. So they all have to change. The way they try to do that is through string theory. It's a little bit more complex than we can talk about here, but that kind of allows them, string theory itself has some problems. It predicts it's not a unique theory. It has 10 to the 500 at least different formulations, which is a problem for string theory, or it used to be a problem. But now that string theory and eternal inflation got together and made an arrangement, we call it, it's a marriage between the two of them. Now it's not a problem that string theory has 10 to the 500 different versions, because there's an infinite number of universes. So every universe gets a different version of string theory. And that explains why the constants are changing from universe to universe. That's actually, we don't really want to argue with scientists about those 2 points. We don't really think they're as good as scientists think they are, but fine. We're not arguing with them about that. The problem, and this is the more abstract point, we're going to develop this a lot in our second season. The problem is it's not enough for scientists to say there's an infinite number of universes and everything happens. Because if that's the case, you can explain everything. Because if there really are an infinite number of universes and everything happens, then there's universes where magic spells work, where I cast a magic spell.
Right.
I think I'm doing something, and then I conjure up a unicorn. I mean, in the multiverse, that actually does happen. That really does happen in the multiverse. And there's multiverses which have, unicorns and Smurfs and chickens and cows. You don't need biology, you don't need evolution, because in an infinite number of universes, and multiverse scientists say this, Alan Guth said, everybody says this, is that everything happens.
Everything possible happens.
Everything possible does happen. So and scientists know this. They know they can't just say there's an infinite number of universe and everything happens, because that explains everything. That explains a divine voice that comes out. There's a finite probability a quantum fluctuation will cause a divine voice to come out of the heavens and say, I am God and a multiverse is false. There are universes in the multiverse where that does happen just by chance. And scientists have to explain, they have to make their theory, they have to try to make it scientific. And the way they do this is by what we call the third premise. They call it the principle of mediocrity. We call the typical universe premise. You want to try to explain that, or?
Okay. So
Good luck.
this is the trickiest part. But basically the idea is that multiverse scientists have to explain our universe. They're trying to explain our universe by chance alone. And they're saying is that there are infinitely many universes out there and everything happens. Well, the assumption is, we are in the most typical universe with intelligent observers. Do we have to be, because we exist, because we're observers, we're intelligent observers. Obviously, we can't exist in all the infinitely many universes that don't have intelligent observers, but we have to exist in a universe with intelligent observers. But there is lots of universes with intelligent observers, not only one. You could have a universe with intelligent observers with just something called a disembodied brain. Sometimes they like a brain in a vat, or they call this a Boltzmann brain problem. You could have just simply one brain, which is the arrangement of my brain at this very moment. You could just have a universe that's all that exists with all my memories. And that could exist.
It does.
It does exist. And there's infinitely many of those. Or you could have a universe that exists that just has one planet with intelligent observers. It doesn't have 100 billion galaxies with 100 billion stars. And the idea is that in this infinite multiverse, which is posited to exist, there are really many, 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 infinitely many universes which have intelligent observers. And multiverse scientists have to claim that we are in the most typical universe with intelligent observers. And that's how you explain everything which we see. Everything we see is a result of chance, is pure chance. And that it only makes sense if you say that we're in a typical universe. If we end up being in a universe which is rigged, seems improbable by chance, then probability isn't going to be a good explanation for our universe. It's unlikely. It's, again, you get to the same problem of the luck, which it doesn't work out. So in order to explain our observations, multiverse physicists have to posit that our universe is the most, of all the universes which contain intelligent observers, ours is the most typical. The probability that we would get ours is a reasonable probability. And this presents a major problem. Again, gets more technical than we can go into right now, but it becomes hard to compute probabilities. If you're really talking about an infinite universe, what does it even mean to have a probability that we're going to exist in the way we do as opposed to some other way? Infinite sets are very hard to take probabilities.
And one thing is again, and they say this, it's not just there's an infinite number of universes and every single possible universe happens. It's every single possible universe happens an infinite number of times. So like there's an infinite number of copies of our exact universe. There's an infinite number of copies of our universe with unicorns walking around. There's an infinite number of universes with, with us and Smurfs, and there's an infinite number of each one. So if every universe has an infinite number of copies of it, how can you say that one is more probable than the next? And if you can't say which one is more probable, then you can't do any science. The whole thing becomes ridiculous. It becomes a joke. In order to make any prediction of any sort of nature and rescue multiverse from being complete trash, you have to be able to say that there is a typical universe with intelligent observers. And in order to do so, you have to introduce something external to the system. It's called a measure, which artificially allows you to take probabilities. That's called the measure problem. And scientists know this is a major problem. And that's ultimately the undoing of multiverse in its own framework, is the introduction of these measures.
The problem is when they introduce these measures, it turns out ostensibly all the measures they try, our universe is not typical.
They don't work out anyway.
They don't work out.
It's the whole thing is complicated. Yeah.
Wow.
We're running short on time. I did want to get into some, at least one theological implication.
Sure.
So we've talked just in the past few minutes, talked about a lot of preposterous explanations, like multiverses and brains in pickle jars. I didn't hear us talk about, there are some people who will say that we are really part of a computer simulation. Some being that lives in 12 dimensions is playing on his computer, and that's what we are. So a lot of very bizarre explanations, which are put out there because basically the assumption is, okay, there's not a God, so how are we going to do this?
Right.
Now, we can also take the assumption that there is some form of a God. And we've already talked, Scott and I have already talked on our episodes several times about how it's just a choice. You can't prove that there is a God. You cannot prove that there is not a God. It's a worldview. You come to the situation with, you assume yes or you assume no, and then proceed from that. And when you come to this problem of how did the universe come into being, if you come with the assumption, okay, there is some kind of a divine being, a God, then things start to make sense. Whereas if you say, no, there is no God, then you come up with answers like multiverses and brains in pickle jars and things. So what's your response to that challenge to the non-theists?
Okay, so I think we're a little bit more ambitious. We think if you come to the universe open-minded, not assuming that there is an intelligent cause or assuming there is no intelligent cause. Don't assume God, don't assume that God doesn't exist. And then you study the universe and you say, based upon a study of the universe, what can you infer about the cause of the universe? We think that if you do that, you will come to the conclusion through the fine-tuning argument. We have two other arguments in season one about the laws themselves, the other initial conditions. Then you will arrive at a very strong, convincing, compelling argument that there is an intelligent cause for the universe. You do not have to assume that God exists. You do not. We don't want you to assume. Come open-minded. We think you will walk away convinced that there is an intelligent cause for the universe. That's the first thing that we don't think that you have to say it's just an assumption, you can't prove it. We're trying to prove it. Now, it's not an absolute proof. It's a rational, convincing argument it's compelling and it'll convince you to really believe that there's an intelligent cause. It's not a proof in the absolute proof, but we do think that you will be able to infer that from the universe itself.
So in summing to a certain extent, what we're saying is that what we observe is pointing us in a direction. It's kind of almost like a big hint that it doesn't explain itself, and it points in the direction of something else, of some external intelligence, some mind. A lot of people talk about mind. That's how it's striking me anyway.
Right. This is a key point. It is, if you were to look at the universe and you were to find that it's like a bunch of garbage everywhere, it's just trash, things don't work out, there's glitches everywhere, and you're just some little intelligent brain that existed for 5 minutes or whatever it is on this planet, then you're going to say, you know what, there's no intelligent cause. I probably live in a multiverse, and there's not an intelligent cause. There's a stupid cause. That's what we would say is, if the universe was a bunch of garbage, then I would say there's an infinitely powerful God who's infinitely stupid. He just makes an infinite number of garbage, and from just by chance, if you throw enough painting at a wall, you'll get something that looks pretty. That would be the proper conclusion. But when we study the universe, we don't find a universe that's largely garbage and trash. We find a universe that everywhere you look, on all orders of magnitude, you find wisdom and you find intelligence, and there's complexity and there's order and there's structure and there's atoms and galaxies and molecules and life. It's amazing. It's wonderful. And everywhere you look, it's not in some place. Everything you study about the universe shows this incredible intelligence. And that's what points you to say the architect of the universe is intelligent. It didn't have to be that way. You could have studied the universe and said, the The one, that calls the universe is kind of intelligent, pretty smart, not that smart, not smart as humans, or you could say it's completely stupid, just got lucky. But that's not what if you come open-minded and you study the universe, you are left with this impression that yes, the cause of this universe is intelligent, and he made the laws of physics for the purpose of producing this incredibly wonderful, amazing universe.
And I'd like to make a point to the listeners. We did an episode about, I think it was 5 weeks ago, with Dr. Chris Berger, who seemed to be making a point very similar to what you're making here. What I heard you say, and Scott summarized it, he basically said when you look with an open mind at the universe, it just points towards some fine-tuning. It points to a tuner. And Dr. Chris Berger's point was we were looking at humans and why we have all this circuitry that seems to see design and a God. And he was talking about how through evolution, humans developed all these abilities, developed this neural wiring and these software routines that pointed them to a designer, to a creator. And it sounds like it's the same sort of idea. But with that, we are getting really short on time. Aaron and Elie, do you have any final words that you want to say? Anything perhaps we didn't cover, or a summary statement of some kind?
Yeah, I just want to make one point is I just, I know if your listeners are critical thinkers, a lot of people are going to have the question of who designed the designer, what caused God. You have all these problems just saying God, and like we're not addressing who caused God, what does God even mean, who designed the designer. Aren't we just begging the question? So there's more to be answered and discussed about God. We do it a little bit on season 1. We're going to do it much more in season 3. And so we're going to take up. And, we feel that we do have answers that are logical and coherent and compelling and intuitive, and they make sense. We don't really have time. I guess we don't have time on this time. Maybe a different time we'll come back and discuss that. But I do know that there is that, like we said in the beginning, you have to address the theological questions. And we do that, just we didn't have time today. So I don't want anybody to walk away thinking we're just saying God and just ignoring. Yeah, go ahead.
That's a really good point.
Okay, Elie?
Yeah, so I guess one point is we kind of touched on this beforehand, but we really think that the argument from fine-tuning is stronger than that, much stronger than the argument from biology. So we know a lot of people are convinced by the argument from biology. I get the sense that you guys aren't super convinced by it, but again, we think that there's, it has its strengths, but we think that if you like we don't want to knock out anybody's argument, and if they think it's compelling, great. But we think the argument from physics is much more robust. It's based upon the foundations of our universe. It's not some emergent phenomenon. It's built into the core of the universe. We think it really clearly avoids the problems of God of the gaps, and we just think it's much more compelling. And to some extent, we explained the physics, but we did talk quickly, and we have a short amount of time. If anyone wants to hear these arguments developed a little bit more slowly, more carefully, with analogies, you don't have to know physics, you don't have to know mathematics. Again, we really took time to try to explain these things very carefully in the episode of Physics to God. So we'd welcome anybody to look into that. And within a few months, we hope to come out with season 2, which is going to go much more depth of the multiverse. And it was really very complicated, but we plan on breaking this all down step by step by step, as we will do in season 3 when we talk about God. So, we'd invite anybody to listen. If anyone has any questions, we'd love to have any feedback. You can just email us at physicstogod@gmail.com. And we'd love to help people see this argument.
Mm-hmm.
And we're going to have links in our show notes for your podcast and for who you are. And people can go there. And we do recommend it. It's entertaining and it's enlightening. So definitely go there. And by the way, Scott, any last comments from you?
No, just only to say that I have found this discussion so enlightening and educational for myself. So I really appreciate your time. And I'm really looking forward to listening to what's coming in the next 2 seasons. So that's great.
Well, thank you.
All right, Elie, Aaron, we really appreciate you coming on. Is there any books? You've talked a lot about future podcasts, but are there any books on this idea?
Our plan is, after we finish season 3, to actually put it all together and reformulate it one final time and make a book out of it. But, the book's been 12 years in the making. It'll be another few years. So
it's going to be a good book.
Exactly.
Okay, Aaron and Elie, thanks so much for joining us. We really appreciate it.
Thanks for having us. It was a pleasure. We
Okay.
really enjoyed your questioning and discussion. We had a great time.
Yeah, thank you.
Thanks again, folks.
Bye-bye.
You've been listening to Recovering Evangelicals with your hosts, Luke Jansen and Scott Dyer. Send your comments and suggestions for new episodes to lukejjansen@gmail.com. Join our private discussion group on Facebook by searching for the Recovering Evangelicals podcast group. Look for the logo that you always see at your favorite podcast catcher and ask to be let in. Subscribe to lukejjansen.wordpress.com if you want to get advanced releases and group posts, or browse through our archive for a full listing of all our previous episodes. And please help the podcast by sharing with a friend and leaving a review at your favorite podcast catcher.